offshore wind is fantastic for a zero emission future. But what about the zero waste future? What about all those blades, all those big poles, and about all those scarce materials that are in them? Is it a one-way street, or can we make this a circular street? To talk about this here is Maarten Lobrecht. Good morning. You are from Echt, and you are part of the DecomCockpit project.
Yes.
What is the DecomCockpit project?
Yeah, it's a consortium of 4 companies. Echt, like you mentioned. SIF, the manufacturer of monopiles. Janssen Recycling Group, they recycle steel, metals, everything. And CRC, and they are specialized in the recycling of blades, so in the composites. And I think then you have everything together.
Okay, the whole value chain.
Yeah.
How did you get involved?
Yeah, I think back in 2020, when the corona starts, at that time the Ministry of Economic Affairs asked Echt to create an overview how circular the Netherlands and Europe was with the wind industry. How circular is it? Mm-hmm. So there we started. We started to research everything. But then after 2 years and a lot of desk work, I wanted to know the wind turbines from the inside. So I evolved into, I think I have to...
Yeah, we have a picture.
Evolved a bit into a quality inspector in wind turbines. So over the last 2-3 years, I've been in, I think, a bit more than 100 wind turbines.
Yeah, this
pictures.
is you in one of them, yeah?
Yeah. To get a practical understanding as well. And I hope to share some of those practical experiences here with the people at the stage.
Yeah, okay. What is the biggest... how is being in a wind turbine different from your insides than sitting at a desk?
Now you see that this wind turbine is made out of so many small components with a huge supply chain. There you see all those names of the companies that are here at this conference. So you get a better understanding where those materials come from and where they maybe should go to.
I'm afraid of heights. Should I ever try to attempt this?
No, okay. Then I will. Yeah, you can stay inside, of course. You can go up, stay inside.
I'll still safely here at the stage.
Okay.
We have a few motions for the audience. We're going to see what they think, and then we're going to ask you to clarify a little bit. The first one we have, you have green and red cards. If you agree with the motion, show me the green side. If you disagree, the red side. If you're colorblind, the German side is if you're against. The first one is, circularity is a no-brainer in view of global warming and scarce resources. Can I see your cards? Okay, well, these are North Korean outcomes, 100%. I'm going to make it a little bit more complicated. If we have to choose, it's better to have clean energy today, even if it has waste, than wasteless clean energy tomorrow. So rather today, clean energy with waste, that's green, or red, we rather wait for tomorrow if we have no waste. Can I see your cards? Ooh, this people find more difficult.
Yeah.
Ooh, still green, so yeah.
Would go for that as well.
And then we are already well on our way of circularity. We're doing it well. Show me the green side if you agree, show me the red side if you think the industry is, ooh, now we're looking at the red, see? So it's important, but speeding up the energy transition is more important, and we're not doing it really well. Is that a good summary of the state of affairs?
It's a good summary, and I think actually with the next slide, I can show that in a few figures. Not sure if it's super visible for everyone.
And we have,
what you see on the top, so we start with this bit of scientific thing, and then we go in the practical side, okay? What you see on here, you see the materials that are mined today, which we need in 2020, 30, 40, and 50. And this is for different metals. For some of those metals, we need to mine 6 times more than we do today. And sometimes we don't even know where are the mines, where is this material in the ground. And the good mines are already taken, right? So this is quite an issue. And if we then take a deep dive into metals in a wind turbine, and you look at that supply chain, then this happens for 80, 90% in Asia. But then when we end at the wind turbine manufacturing, that's happening in Europe. So you see a big demand of more materials, while the supply chain is maybe difficult for the future for Europe. So this is why we need to use every turbine that's already in Europe today and use that as optimal as possible to create new turbines.
You're talking now about the scarce metals, mostly, most of the copper and all the metals we need in the electronics in the wind turbines. The populistic parties that are against wind turbines always say, yeah, but look at the blades, you can't recycle them, we'll have massive graveyards of these blades. Is that also an issue?
That is also an issue. So you have it on two sides, the mining, the new materials, and then the waste. But for metals, there is quite a good supply chain already. But for the composites, that's now starting. At this moment, there are now tests with a new manufacturing plant in Rotterdam to manufacture those composites. So things are happening. I saw a lot of red cards, but maybe in a year you will turn them green when you see the videos of this recycling process.
And for the composites, is it because of scarcity or because we have so much waste?
That's the waste problem. Yeah, okay. There's no scarcity of
no
sand.
No scarcity, but just we don't know where to leave all the things. Let's go to the second motion. Circularity goes beyond recycling. So show me green if you think it's more. Show me red, you say if we recycle, we are circular. Oh, this is also not very controversial. Everybody says it's more.
I didn't want a difficult presentation today. I want everyone to agree. And
then early morning,
Yeah. So, but I want to explain it, and that will be the last graph, and then we will go in pictures. I want to explain it with the next slide, where I show that people talk about recycling, but recycling is just one step. It's scrapping it back to in the smelting manufacturing. But you can use it in many more ways. You can repair stuff, refurbish, repurpose, a lot of those names, which we all should use as good as possible. So I think I have to click to the next one. This is the process of making a wind turbine, manufacturing, transport, operation. And then either it's non-circular and you burn the stuff, or you landfill it, the graveyard you talked about, or you bring it back, extend life, bring it back in this value chain. So that's the difference. Good to keep that in mind. Don't always talk about recycling, talk about circular processing, because there are so many steps.
You're talking about, well, we have all these wind turbines now. Can we do something with them, or do you need to incorporate circularity in the design? And you can only do proper circularity if they are designed in a circular way.
In design and in thinking. I can show you an example of a project where I worked on a few years back of a damaged blade. So I think we can go to that. Here you see a blade, quite heavily damaged, 2 meters long, huge scratches. And then the project manager came to me as the quality manager and said, I want a new blade. And I could understand, because from my quality perspective, I want a new blade as well. But from this circular thinking, this will mean that a 70-meter long blade will be burned, and that's not what we want. Yep. So together with the engineers, we sat down and we said, okay, we will repair it, and if it has issues later, then we will replace it. But now it's already a few years running with a repaired blade. So here, instead of burning it on day one, it can probably run for 20 years. And that's the process you see here.
Okay, so we have circularity, but then we have quality. Well, you say we can do that.
Yep.
Then there is money. Mm-hmm. Is this more expensive or is it cheaper?
This is cheaper as long as it will not be replaced, as long as the repair stays well.
Yeah. Yeah. And then the fourth question, speed. Do we have time for circular design and execution if we look at all our climate ambitions for 2030 and 2040?
Yeah, and I think we need to, because we already see a big shortage in copper. So 5% of all the projects in the world are now delayed because of a copper shortage. So we need the speed going with retrieving all the copper from the turbines that are there today. So, yeah. So
they're not excluding each other, they're even strengthening each other.
They're strengthening each other.
Okay, yeah. Well, let's go to our next statement.
We still, so this is the good thing, eh? Talking about circularity, this blade is now not gone. It's stood there for 20 years, and then either you can put it in this graveyard, Or you could cut it in smaller pieces and make something like a chair out of it, right? And then place it here at this exhibition. And then people see actually your waste being used, optimized. Then you see, okay, from one blade you can make 40 chairs. Ooh, that's a lot of waste, right? People get to think about it.
Okay.
And then after 10 years, we don't want this chair anymore. So what do you do then? From this chair, you can recycle it. That's what the company CRC in Rotterdam is doing. And then this recycling is basically bringing it back to small particles. And from these small particles, you can mold that again with some resin in new components. And you can reuse that in wind turbines as well, like the roof of the wind turbine or the gratings at secondary steel. The gratings, they are made from plastics as well. So you can then keep using it in this wind turbine. So then in the end, instead of, again, burning it on day one, we are now 20 years as a chair in the office, 20 years spinning, and then thereafter 20 years. And this is all possible. This is no science fiction. This is possible.
Yeah. Wow. Cool. Let's go to our next station. Next statement. Circularity is pivotal in acquiring future projects. So show me green if you think we need a circular design and incorporate in project, or red, it's nice to have, but it's not need to have. I see green cards coming. Yeah, is it nice to have or need to have?
Yeah, this time it's a nice to have. It's not needed. Until the latest tender in the Netherlands. So that's the first one. But if you want to develop a wind farm in Germany or anything, you don't need circularity at this moment. But now in the Netherlands, they have this new wind farm, IJmuidenver, and their circularity is actually a criteria. So if you do not give insights in your materials, in all the things you do, then you will not win. It's 10% of all points. So for that specific one, it is pivotal. And then, of course, you can say it's only pivotal for the developers that write this nice tender bit. But hey, they will go to the supply chain and say, oh, I need to have a generator that is recycled and that has this and this. And then the whole supply chain, which is here at the conference, they need to think as well, where do our materials come from?
And in this, is it most important you show we use recycled to reused materials, or we use new materials, but they can be recycled or be reused?
Yeah, both. Yeah, both.
Okay, so you have to think...
Both are possible. You need to give your methods, you state the methods that you use. And if your method is we use recycled materials, that's a method. And if you say we design something which can be recycled, that's also a method. But it's in the decommissioning.
And can you choose where you focus on? Can you say, well, we focus on the blades, not the copper, or we focus on the copper, not the blades? Or is it also prescribed in the tenders?
No, you can. It's a bit described, but you can focus for sure. Yeah, yeah. And that's cool, right? Because then you can be unique.
Yeah, is creativity in circularity going to make the difference between winning and not winning the bid?
This time, I would say not. But hey, last year we had the same thing with ecology happening. There they said, do something with ecology. And then the year after, it was booming in the next tender. So this is just the start. And next tenders, I expect, I'm not sure if I see something from someone from the government, but I expect that in this next tender, there will be much more creativity points for circularity.
Okay, so then that brings us to our next statement. Circularity can give your company a leading edge. So show me green if you think it's going to make us money, or red, it's just some annoying thing we have to do. But, again, 100% green score.
This was the idea. First, to show that there is scarcity in materials, a problem with waste, there are opportunities. And now I saw everybody green, and we wanted this one to be green. Because we want people to go home and think, OK, materials, we need to make them transparent, and we need to be circular. And this is very important. And I can maybe show the next slide on this.
Yeah, go ahead.
Yeah. It's shortly what we do within the DecomCockpit, and to give you some examples of the companies, how they have made a step to be more circular already, as an example. So if we go one further, we have SIF. They make monopiles. It's one of the the proud companies from the Netherlands, right, in the value chain of wind energy. And they said, now we want to take all those monopiles back. So recycle them themselves.
Yeah.
And this is not only saying stuff, they actually created this company already. There's a new BV, you can search it. And they are preparing a new line to recycle those monopiles. That's a huge investment, but that's taking responsibility of the products you make. So they will probably design the monopiles in such a way that you can take them easier out or whatever and use them in the circular process.
If I also want to get started with this, where do I start?
Where do you start? Now, first, you can always talk with me. I am happy to work with you on that. Where do you start? Start with making the materials you use transparent. Just ask, oh, where does this come from? Where does my metal come from? And then if you see where it comes from, then you probably know, we might need to change this, right, to another supplier, which is more circular. And then you understand how you can make your process also more circular in your design. So start with the materials.
We see European regulation about ESG and the deforestation regulation. There's more and more regulation coming that makes you, that obliges you to make your whole value chain transparent. So basically, you have to do this anyway.
Yeah.
So you might as well use it.
But start today, because if you start today and you see that your supply chain is something that is quite in a closed box, right? You use this already for 10 years, the same suppliers. But start today, and if you see that there are flaws in your supply chain, then now you can change it. But in 4 years, when this legislation is there, then everyone wants the most green supplier, and then that will be an issue for you.
Then we have it transparent, but you have to redesign your supply chain, because my supply chain used to be one way. Materials come this way, money goes that way.
Yeah.
Now I have to make a circular supply chain.
Yeah.
Where do I start?
Hire people, create. No, it's how do you start? It's something you can do in this consortium, right? Because a company like Civ is very good in making steel.
Yeah.
But making all those materials transparent, that's something where a company like Echt steps in. So to make these material passports and to go through this value chain. So that's an example of how you then need to collaborate, like the two persons before me also said. We need to further collaborate, also on this circular loop.
Well, we need to collaborate, but on the other hand, you're just saying this can give you a competitive edge. So yes, I want to collaborate, but I don't want to give my secrets away to my competitor because I want to keep my competitive edge.
Yeah.
So should I be transparent or not?
This is a very good one. At this moment, the wind industry is a bit in the shaking, like how transparent should we be? But you can be transparent on certain levels. You sometimes don't need to share every gram of specific components, but start with this breakdown. What's in your wind turbine and share that. Like the cooling system, the generator, the motor, the gearbox. That's all known knowledge, but only for the manufacturer and not for the people, the recyclers, that need to recycle the components. I can give a nice example.
Yeah.
A recycler was cutting a blade, and at a certain moment, there was a small, nobody was harmed, a small explosion, a fire issue. Why? Cutting a blade. What could explode in a blade? It was a battery. There is a battery in some blades, electrical pitched blades, there is a battery. And this battery was still in there and they didn't know. But if you have this good overview, this material passport, then you know, oh, there is a battery there, so I might need to remove it before I start to cut it. Right? And this battery, this is no intellectual property that there is a battery in a blade. That's known. And this battery, you can just say the supplier, battery, this type, and then you can ask to them.
Yeah.
So you can, a lot of people are, oh, we won't share everything, but some of those components are just known. So be transparent.
If we looked at industry 10 years from now, if you can make a crazy prediction about how circularity is going to disrupt the industry.
Yeah, I think at this moment the legislation is focusing on this producer's responsibility. So if the Vestas or Nordex makes a blade, they probably need to take it back. That's a lot of extra work for this company that already has so much challenges. So I'm hoping that this legislation is not killing such companies, because there's too much pressure maybe on them. So I hope that we can find a good balance, that there should be taken responsibility, also a bit by the developers, the Vattenfall, Ørsted, Eneco, those ones. Because they owned the product for 30 years. And they also, in my opinion, have a certain responsibility to show that these materials are processed in a circular way.
Is the so you already say it's going to be an obligation in tenders. Mm-hmm. There is a financial incentive. Mm-hmm. Some materials are just really worth lots of money. Is that enough incentive to get circularity going, or do we need a lot more carrots, sticks, and preaches?
Now, if there is money to be made, then people will do it. That's how it works, right? Yeah. And let's go in scrap metal, for instance. If you recycle that in a very pure way, you can get 2 times more than when you have the bad scrap metal, right? It's improving your processes and get more money back from it. So if there is money, people will start to innovate, right, and work and join this movement of circularity.
So you need to do it. There's money to be made.
Yeah.
And it's safer if you do it well.
Yeah.
What's keeping us?
What's keeping us? I think just we need to change our whole thinking process, right? It goes from one to another to a recycler, and then it's gone. But this shared responsibility that your turbine will not end up somewhere at this graveyard, that's something we have never thought about. We as Echt are also working with developers, and sometimes you don't see. It's so difficult to have this incentive through the whole value chain that they understand that we need to do something with these materials again. But it's so easy. There's 250 gigawatt of wind turbines standing there in the North Sea, in Europe, in Spain. You see, there are your materials. Use them again.
Makes sense.
Yeah.
If people want to know more about it, where can they find you?
I will stay here, I guess, for half an hour, and then you can recognize me with the vest like you have.
Yes, right. And definitely tonight also at the networking drinks. Go find you, and let's have a circular future.
Yeah.
Thank you so much, Maarten Lobrecht.